Today we are going to study Newton's third law. Our goal is to apply Newton's third law to scientific problems. So today we're going to look at some examples, and you're going to actually put these examples into your own words. But first, let's review. Newton's first law states an object at rest will stay at rest unless acted upon by an unbalanced force. An object in motion will stay in motion unless acted upon by an unbalanced force. That means if the velocity is 0, then the object remains at rest. This is normally taken as the definition of inertia. We remember, inertia is a property of matter. What does that mean? Well, that takes us to Newton's second law. Force is equal to mass multiplied by the acceleration, or shortened to F equals ma. The more stuff, the more you need to make it accelerate, the more force you need to make it accelerate. So mass multiplied by your acceleration is equal to the force. And we remember that we measure force in newtons. If you need to go back to either of the previous videos, please do so in order to refresh your memory of Newton's first and second laws. That's going to bring us to Newton's third law of motion. For every action, there is an equal and opposite reaction. And though this phrase you may have heard before, probably used in more metaphorical purposes, perhaps in Hamilton, for example, this is really important in physics, and it has a quantitative measurement to it. In physics, this means that if you exert a force on an object, it exerts an equal force back on you. When two objects interact, then the forces they impart will be equal in magnitude and opposite in direction. This is what we call the normal force. Normal in this instance means perpendicular, and the normal force is always perpendicular. If you think of a book sitting on a desk, the book is pushing down on the desk, and the desk is pushing back onto the book with the same force. Therefore, the book is not moving. The normal force is special because it can change its magnitude. The more force we have, the more opposite direction pushback we have. So thinking about more weight on the table, more books on a bookshelf, the more mass put on those bookshelves, more books equals more that the bookshelf is going to hold up. And it can change. If there, of course, is too much weight on the bookshelf, then the books would collapse, or the bookshelf would collapse. It can no longer hold that weight. And that is because the reaction has to change in order to keep the action in place. When the normal force can't match the force pushing against it, that's when the exciting things happen. That's when things move, or it changes. So action, reaction. Why can things move? Well, things can move because there's more going on than just the action and the reaction forces. If you have a force that is stronger, then that's when you can have things move or jump. Let's look at some more examples. When a rocket ignites, the thrust from the engine goes towards the earth, but the rocket moves in the opposite direction because the force from the rocket is greater than gravity. How can we move in the opposite direction? Well, if I was standing on a skateboard and pushed against a wall, I would move in the opposite direction because I would, of course, bounce off the wall and go in the opposite direction. What about an untied balloon? What would happen if I let an untied balloon go? Well, when I let go of an untied balloon, the air would flow out of the balloon in one direction, but the balloon would fly away in the opposite direction. Again, action, reaction. Use your examples in the accompanying foldable to write in your own words what would happen in all of these scenarios. Explain in your own words how a rocket is able to lift off. Explain in your own words what would happen if you were standing on a skateboard and then pushed a wall. Finally, explain what would happen in your own words if you were to let an untied balloon go. Why would it act this way? Go ahead and pause the video and answer these questions in your own words. You can see how I structured my foldable. Of course, your wording will be slightly different than mine, but if you like, you can pause the video and double check to make sure you have everything. In today's video, we looked at several examples of Newton's third law of motion. For every action, there is an equal and opposite reaction. I hope you found that helpful, and I hope you were able to put Newton's third law into your own words. Have a great day. Thanks again for watching. Bye.